In part 4D of our position and time lab, you're asked to pick 2 points near the bottom of the graph and 2 points near the top of the graph. Then it asks you to draw 2 triangles and to calculate the speed from the slope. Now some of you have covered slope in math, but some of you have not. And this is just will be a little refresher or a tutorial for using a graph to calculate slope, which in turn means you're calculating the speed of the car between those 2 data points. So on your table, you should have already calculated the speed and for both A and B. But in your graph, you're using the distance from A to B, which is this column, that's your y-axis, and your x-axis is the time from A to B, so that interval time. So this is your x-axis. Now at this point your graph should already be done. However, if it's not done, please be sure that you've used the time from A to B on your x-axis and the distance from A to B on your y, and you followed the suggested scaling that was on the board. So when I make a graph, I really like to put my points on the graph itself to make my calculations that I'm going to do a lot easier. So for our example today, I'm going to make a triangle using these 2 points, and then I'll choose another one near the top. My first step is I'm going to use a ruler to draw a straight line between the 2 points. Then I'm going to make my legs of the triangle like so. So I'm going to go over from one point till I'm right under the other, and then I'm going to go from the top point down until it meets that line. Now in math, you've learned that the slope, which stands for m, is equal to rise over run. So what that's going to mean is that we're going to take the difference between our y values and then over the difference of our x values. So if we go to the back side of the page, I'm going to split this part into 2. And I'm going to say, okay, I have the blue triangle. So if I know that slope is equal to rise over run, I need to take the difference between my x values, which if I go back, if I'm starting at 20, I'm going to subtract 10 to get the difference, which is 10 centimeters. So I'm going to do 20 minus 10, and it's going to be over the run, which is the difference in the x-axis, and we want it to be positive, so we're going to put our biggest number first. So it's going to be 0.2330 minus 0.1374. So on my paper, I'm going to put 0.2330 minus 0.1374. Remember, this was in centimeters because our y-axis was in centimeters, and the x-axis is in seconds. So then I'm going to do some math. So 20 minus 10 is 10 centimeters over 0.2330 minus 0.1374 is equal to 0.0956. And if I do that, oh, that's seconds. And if I do that division, I'm going to get an answer of 104.6. But then I have a unit in centimeters over seconds. So what I've done is I've used a graph that was positioned in time to calculate the speed of an object using its slope. So by doing this, this line between my 2 dots and my hypotenuse of my blue triangle is telling me that the speed between 10 centimeters and 20 centimeters, the car was going at a speed of 104.6 centimeters per second. So now we're going to pick another set of data points on top. And I'm going to change my color, and I'm going to choose these 2 top ones. So I'm going to use a ruler again to make a straight line between these 2 dots. I'm going to go from the bottom dot over to that other dot that's on top, and then go from the top dot down till I meet that line. This helps you visualize the rise and the run of what you're going to be calculating. So for my green triangle, I know that the slope is equal to rise over run. And again, we're taking the difference between those 2 points. So if I'm doing rise first, that's my y-axis. These are these back numbers. So it's going to be 80 minus 70. So 80 minus 70. That unit was in centimeters because that was my y-axis, over the run, which is the change in the x. So it's going to be 0.5659. We always put the bigger number first, minus 0.5176. So I'm going to write that down. So 0.5659 minus 0.5176. So this is going to be equal to 10 centimeters over, I need to take out my calculator, so 0.5659 minus 0.5176. Did not do that correctly, so 0.5659 minus 0.5176. That looks a lot better, so 0.0483. So 0.0483, that unit's going to be in seconds. So 10 divided by 0.0483 gives us an answer of 207.04. So 207.04. And we always need a unit in physics, so it's going to be centimeters over seconds, because that was the units we were given here. So what this tells us that the speed of the car between 70 and 80 centimeters was 207.04 centimeters per second. So this is how you do part D. So I want you to model what we just did in the video on your own paper.